Hello again. In this video, I'm going to go over this homework problem from 3.8. And so in this problem, we're supposed to use implicit differentiation to find the derivative of y with respect to x. And this is the equation that we're given. Now notice in this equation that solving for y is either impossible or very difficult because y appears inside of this sine function. And it also appears over here. So in order to solve for this y, you would have to somehow isolate it. And since we can't get y isolated, we can't use normal differentiation to find this dy dx. And so instead of trying to isolate the y first, we're going to just use implicit differentiation. Okay, that's the reason you would use implicit differentiation, by the way, is because you cannot get y by itself. If you could get y by itself, then you would just use normal differentiation, okay? But in this case, we can't get y by itself, so we're forced to use implicit differentiation. Okay, so let me show you how you can do this. So the first step in implicit differentiation is to take the derivative of both sides of the equation with respect to x. Now notice that these remain equal. Since they're equal up here, these two are equal. When I take the derivative of the left side with respect to x, as long as I take the derivative of the right-hand side with respect to x, then they'll remain equal. Whatever I do to one side, if I do it to the other, it maintains the equality of the two. Okay, so they're still equal. Now, let's find the derivative of the right-hand side first. Now, you're allowed to break this up across addition. That's one of the rules of differentiation. Okay, so we can break this up. Across addition. So the derivative of 2x plus 9y is the same as the derivative of 2x plus the derivative of 9y. Okay, and then we're going to do each of these derivatives separately. So notice you're allowed to pull constants outside of the derivative operator. So that's another rule of derivatives. Okay, so I can pull the 2 out. And then I can also pull the 9 out since it's a constant. Okay, and by the way, this is called a derivative operator. Okay, so basically what the rule says is if you're taking the derivative of something like 2 times x, that's the same as 2 times the derivative of x. So you're allowed to pull the 2 out of the derivative operator. Likewise here, you can pull the 9 out of this derivative operator. Okay, now we're just left with the derivative of x with respect to x, and that's just equal to 1. You can use the power rule to find this. This is like x to the first power. So when you find the derivative using the power rule, you'd pull the 1 down in front, and you would subtract 1 from the exponent, and you would get x to the 0 power. And x to the 0 power is 1. So you just get 2 times 1, and that's equal to 2. Okay, and then this derivative we can't actually compute. We just have to leave it as the derivative of y with respect to x, and if you want, you could write it like this. They're the same thing, and then the 9 goes in front and gets multiplied by that. Now, we can't compute this derivative because we don't know what y is as a function of x. That's the only way you can compute this derivative. If you're going to take this derivative with respect to x, then you need to know what y is equal to in terms of x, and we don't. And so there's no way for us to actually compute this derivative. We just have to leave it as the derivative of y with respect to x, whatever that is. Okay, so that's the right-hand side. Now, the left-hand side, again, we can pull this 5 out front because that's a constant. So we get 5 times the derivative of sine of xy. And then we just have to compute this derivative. But in order to compute this derivative, we're going to have to use the chain rule. And the reason we're going to have to use the chain rule is because this sine of xy is really a composition of two functions. Sine is the outer function, and xy is the inner function. So it's a composition of those two functions. Okay, so we're going to have to use the chain rule to find this derivative. Remember, the chain rule, you have to use the chain rule anytime you take the derivative of a composition of functions. Okay, and so that's what we have here. And just as a reminder, the derivative of a composition of two functions, right, f composed with g, the derivative of that is f prime evaluated at g of x times, and this should be g prime of x. Okay. This is called the outer derivative, and this one's called the inner derivative. Okay, so basically you have to find the outer derivative and multiply it by the inner derivative. Okay, so let's kind of write this out. In this case, the outer function for this composition would be sine. Sine of x. So that's my outer function. Whereas the inner function is just xy. Okay, so we're taking this function and we're kind of shoving it into this sine function, and that's why we're getting sine of xy. So it's a composition of these two functions. Okay, and so the first thing we have to do here is find f prime of x. Okay, so the derivative of sine is cosine. And then we have to take that derivative and evaluate it at the inner function. Okay, because g of x is the inner function, right? And in this case, our inner function is xy. So we have to take the derivative of f and evaluate it at the inner function, okay, which is xy. And of course, when you evaluate cosine of x at xy, you just get cosine of xy. Okay, and this is called your outer derivative. Okay, and then now we have to find the inner derivative, right? This is your outer derivative, and this one's your inner derivative. Okay, and now to find the inner derivative, we're just going to take the derivative of the inner function with respect to x. Okay, now in order to find this derivative, we're going to have to use the product rule because this is a product of two different functions, right? It's x times y. So x is the first and y is the second. Okay, and so in the product rule says you take the first function, which is x, and you multiply it by the derivative of the second function. Okay, the second function is y. And so we take the derivative of y with respect to x, right? Because this derivative is with respect to x. Okay, so that's the first function times the derivative of this second function with respect to x. Okay, and then you take the second function, which is y, and you multiply it by the derivative of the first function with respect to x. And of course, the first function is just x. Okay, now this derivative we can actually compute, right? The derivative of x with respect to x is 1, so you just end up with y, right? Y times 1. But this one, again, we can't compute that one because we don't know y is a function of x. So we're just going to leave it as dy dx. Okay, so this is your inner derivative. Okay, and then all we have to do now is take the outer derivative and multiply it by the inner derivative, and that will give us the derivative of this composition. Okay, so I'm just going to write that in here. So it's 5 times, okay, so the outer derivative is cosine of xy. Okay, and I'm just going to put parentheses around that to make it clear. And then times the inner derivative, which is x times dy dx plus y. Okay, and I really don't need this bracket. It just makes it more confusing. I'm going to take this bracket off. This 5 just sits in front though. Okay, so 5 times cosine of xy, okay, that's your outer derivative. The cosine of xy is your outer derivative, and this is times your inner derivative. Okay, and make sure you put parentheses around this inner derivative. Okay, and then I'm just going to distribute this 5 cosine of xy to both of these terms. In fact, I'm going to put the, so you get 5x cosine of xy. I'm going to put the x up front, so let me erase this. Okay, that doesn't seem to be erasing, but I'm going to put 5x in front. Okay. That looks like a negative, so let's see if I can't get that erased. Okay, so when you distribute this to the first one, right, you get the order in which you multiply doesn't matter, right? But so you get 5 times x, and then you could write cosine of xy next, and then dy dx last. I'm just going to put it in that order. Okay, and then distribute it to the y, and you get 5y cosine of xy. Okay, so that's what you get when you distribute the 5 cosine of xy to both terms. Now, in this problem, we're supposed to find dy dx, right? So we're supposed to isolate that. And notice we have a dy dx in 2 different terms, right? We have the dy dx over here, and we have a dy dx over here. Now we have to isolate that dy dx and solve for it. So how are we going to do that? Because we got 2 of them, right? Well, in cases like this, where you have more than one of them, you need to make sure you get all the dy dx terms on one side and all the terms that do not have a dy dx term in it on the other side. Okay, so these 2 terms, right, this one has a dy dx in it and this one has a dy dx in it, they have to be on the same side. Okay, so I'm going to subtract this 9 dy dx to the left side. And then this term here does not have a dy dx in it. That needs to be on the other side, okay, with this other term that does not have a dy dx in it. So I'm going to subtract this term here to the right-hand side. Okay, so notice what I've done here. I've gotten the dy dx terms on one side, right, the left side, and I've gotten all the terms without a dy dx in it on the right-hand side, the other side. Okay, now the reason I'm doing that is because then once you've done that, you can factor the dy dx out of the left-hand side here. So I'm just going to factor that out. Okay, of course, when you factor out of here, you're left with 5x cosine of xy, and when you factor it out of here, you're left with a minus 9. And then just to finish this off, now remember, you're trying to get this by itself, right? This dy dx by itself. I just need to divide this term here to the other side, okay? And so if you do that, you're left with dy dx is equal to, 2 minus 5y cosine of xy all divided by this term here, 5x cosine of xy minus 9. Okay, and so that's the derivative of y with respect to x. Now, one thing to notice in this is this derivative, dy dx, is written in terms of both x and y. And that often that happens when you perform implicit differentiation. When you perform explicit differentiation in the past, right, when we've done that, we've always ended up with our derivative having as being a function of just x. In this case, because we used implicit differentiation, we ended up with our derivative in terms of both x and y. Okay, but that's the price we pay for using implicit differentiation. Often that happens. Okay, so let's just double check this and see if we got the right answer. So this is the correct answer in MyMathLab, and you can see that that's the same answer that they got. Okay, so I hope you found this video helpful. Again, I'll continue to work out some homework problems from Chapter 3, and hopefully you'll get a chance to look at some of those videos as well. Okay, bye-bye.